Okay. Okay. So last time we did an example. This line integral. It says right here, we want to find the line integral for closed curve. For closed curve given y equals to x squared and then x equals to y squared, and it's given the function for p and then q. So you need to find both. Okay, so kita on y equals to x squared, you just substitute anything y becomes x. Okay, so maksudnya yang tadi apa dia? So this one has y, it becomes 2x cubed. So you have y right here, this is y. Okay, pxy squared. And then dekat sini pun saya ada y, so this is also y. Y equals to x squared. Kemudian saya gantikan dy. So gantikan dy, this dy. Kemudian, and then after that, we use regular integration, just a simple integration, and you get the answer 7/6. So yang ni hanya, this is only from, I heard something. Okay, so yang ni semua dari, so this is from 0 to 1. So this is on y equals to x squared. So saya kena gantikan dy. Alright, so along, and the next step is kita nak cari daripada from 1, point number 1 to point at the origin. Okay, so this is the equation is x equals to y squared. So I want substitute, just substitute x. So this is x equals to y squared, and then this is x equals to y squared. Okay, so gantikan saja, so, and then solve p and q untuk dy. Kemudian cari dia punya dx. So this is the dx. dx is 2y dy. Okay. And then this is the original function. This is original p dx plus q dy. Okay. So everything dx becomes dy. So this is in terms of y. This is in terms of y. This is also in terms of y. Okay. Y goes from 1 to 0. So you just do regular integration and then you get the value. And then because this is a closed curve, so closed curve you need to add both. Yang tadi daripada, so this is from 0 to 1, you get 7/6. So 0 to 1. And then from 1 to 0, you get minus 17/15. So kena tambah kedua-duanya dan dapat 1/30. Okay. Let's do one more example and then we can continue to our next lesson. Okay, for example, it says here, evaluate the curve line integration for 2xy dx plus x squared plus y squared dy. Okay. Okay, so kalau tengok kat sini, if you see this is almost the same with this question, but a slightly different P and Q. So yang ni cuma ada X dan Y. X to the power of 1. Okay, so just slightly different. Okay, so what about the line? So what about the curve? So dia kata on circular curve, circular. On circular curve C given by x equals to cosine of t and y equals to sine of t, and t goes from 0 to pi half. Okay, so first of all, kita kena sketch dulu, because now we can see the region. So dia kata apa? So kalau tengok kat sini, circular curve given by x cosine t, so that's like a circle, equation of circle. So if you go for on the xy Cartesian coordinate, okay, so this is just a circle, something like that. Tak cantik. Alright, macam itulah. So this is the curve C. T from 0 to pi half. So this is the angle from 0 to 90 degrees. So this is the C. How about the radius? The radius, because this one is coefficient is 1, so it goes from 1 to 1. So only on this line, dekat atas ni sahaja. So meaning that kalau dalam case ni dia cuma atas curve circle, dia tidak, this is not a closed curve. This is just a regular curve. Okay, so what to do? Evaluate as usual. So we have on curve C, we have 2xy dx plus x squared plus y squared dy. Okay, so everything, every variable, so everything right here, you need to change according to the parametric equation. Apa maksud parametric equation? So x and y in terms of other variables. Alhamdulillah. All right. So we need to determine the range for x. So this is like from x1 to x2, and then from y1 to y2. Okay, so we need to determine that. Okay, let's see 2xy dengan dx. Let's see, this one is first. Kita ambil yang ni dahulu. So we take this one first. Okay. And then kita nak buat dalam bentuk t. So integrate. Let's see. This is, let's say this is 1. So for part 1, we need to integrate 2x on the C curve, 2xy dx. Kita buat slow sikit, takut nanti nanti hantar ni. Okay, so t, we need to change x in terms of t. So x should change in terms of t. Okay, so maksudnya kat sini kena ada dt. On this should be a dt. So 2 x tu apa? X adalah cosine of t. Y is sine of t. How about dx? Dx adalah times d over dx of cosine t dt. So saya cuma buat apa? So the only thing that I do is this is x, this is x, okay, and this is y, This is y. Lastly, this is dx. So this is the dx. How the limit for t is what is given right here from 0 to pi over 2. So saya buat apa sekarang ni? Saya cuma substitute sahaja. Just substitute the parametric equation. Okay, so apa jadi? So this is equals to from 0 to pi half to cosine t, dia akan jadi sin minus sin. So minus saya letak kat sini, minus minus 2 cosine t times sin squared t dt. Okay, so saya boleh buat apa dia ni? Saya boleh buat use substitution. Okay, so you can say like u equals to sin t, so du equals to sin squared t. So du, tak nak guna sin squared. U, saya boleh buat u equals to sin cube t, sebab dia ada sin dan cosine. So du is just 3 cosine t times sin squared t dt. Okay, so awak dah nampak dia punya ni. Okay, so just evaluate from 0 to 2 pi and the answer will be, so it will be minus 2 over 3 sine cube t, evaluate from 0 to pi over 2. So that will be minus 2 over 3. Sine 0 is 0, sine pi over 2 is 1. Okay, so we get one of the integration. Okay, the next one is the second part on y, on dy. Okay, the same thing. Apa kita buat? So this is from on c x squared plus y squared dy. Okay, so just put everything into t. X squared is just cosine squared t plus sine squared t. Okay, so this correspond to x squared. This correspond to y squared. Okay, and then dt, not dt, dy. So y is sine t, so dy is cosine t dt. Okay, so this will be cosine t dt. T integrate from 0 to pi half, doesn't change. Okay, so you can see that this is quite easy. From 0 to pi half, this is becomes 1, just cosine t dt. So this is just a sine t from 0 to pi half, which is equals to 1. Okay, so the whole thing is just add the integral for, so from c of p dx plus q dy. So this is equals to minus 2/3 plus 1. So this is just 1 over 3. Okay, any questions so far? So this is quite straightforward, right? Because you are given the parametric equation. So if you are not given the parametric equation, that will be a really quite hard problems. But in most cases, if you have a circle, something like this, it is using cosine and sine. And then you just look at the the boundaries on the parametric variable. Okay, so if you don't have any question, then let go to our next topic, which is sequence and series. Saya nak tersebut apa ni sekali semua. Okay, sequence and series. Okay, so first of all, ada siapa tahu apa beza di antara sequence and series? Okay, so kalau tak ada siapa tahu, saya akan jelaskan during this lesson. Okay, apa maksud sequence? Sequence is a function. So it's like a function. And the domain is set of real numbers. It can be real numbers, it can be complex numbers, it depends on your sequence. Okay, for example, if I have 2, 4, 6, 8, 10, 12, and so on. Semua nampak ke? Ni sebab saya tukar dia punya ni. Ada yang tak nampak dia punya ni screen tak?
Nampak.
Nampak eh?
Nampak.
Okay. So sequence kat sini. Kalau awak tengok. So this is like even number. This is even number. Even positive real numbers, integers. Even positive integers. Okay, so because it has 2, 4, 6, 8, and so on. So this is like an infinite series or infinite sequence of even and positive integers. Okay, let's see. Let's see the terminology. The first thing is terms, number of terms. Okay, so yang pertama, this is the first one. So this is the first one. Let's say this is, let's use I. So I equals to 1 is 2. I equals to 2 is 4. I equals to 3 is 6, and so on. So in this case, this is called the first terms. 2 is first terms. Okay, mungkin saya slow-slow sikit sebab apa? Sebab nanti dia akan melibatkan satu benda yang lebih besar. So kita jelaskan dia punya terminologi dulu. Okay, and then number 4 is the second term. Okay, and so on. Okay, and then the number of terms, kalau ada banyak-banyak macam ni, if you have a lot of this, you have, for example, let's say at these terms, more than you can count. So this is called the number, let's say, the formula. Let's look at formula of sequence. Kalau kat sini, this is just 2 by n, 2n. And then n start from 1, 2, and so on. Okay, so let's say if I want to find n equals to 4. So when n equals to 4, my term will be, this is the fourth term. So n equals to 4, which is equals to 8. Okay. So yang ni senang je lah sebab dia cuma even numbers. Okay, so and then if you have a lot of this, you can say this is, let's say this is U. So this set, let's say this set is equals to U of n. So it can be the number of infinite numbers of sequence. So this is the nth term. This, and then saya nak jadi yang dia bersambung. So this is n term. So kalau saya nak merujuk kepada, if I want to refer to any number inside, I can say is it the first term, second term, and then if I want to refer to arbitrary number, saya boleh kata this is the nth term. So the nth term, and this is n terms, and then the next after nth term is n plus 1 terms, and so on. You can also have this one, this is n minus 1 term. So this is just the terminology. Some sequence is easy to find the formula. Some are not that quite explicit. You have to figure out how to find the formula. Okay, so how to write this formula? You can say this, since this is a this is what this is even number, you can say the how to write this is just 2n and then n start from 1 until positive infinity. So this is equals to what? 2, 4, 6, 8, and so on. So this is how you write the sequence. So this is like a set of numbers. Okay, let's see how about this one. How about try to find the formula for another sequence. One over 2, 2 over 3, 3 over 4, 4 over 5. Okay. Try to figure out the formula for this one. Okay, you can see the first term, this is n equals to 1, n equals to 2, n equals to 3, n equals to 4. Okay, if you see that there is like macam ada kaitan dengan n sebutan ni. Okay, so when n equals to 1, the denominator, not denominator, the numerator is equals to n. But the denom is plus 1. So this is just equals to 1. This is 1 plus 1. Okay, let's see the next one. The numerator is equals to 2, which is equals to the number of terms. But this one is 2 plus 1. 3 is 2 plus 1. And let's look at the third term is also equals to the third term, and then the numerator is just not that color. You just add okay, dia ada macam tak nak ambil saya punya juga. hold on 1 second. Dia macam hold on. Okay. Okay, let's see. So this is 4. 4 is 3 plus 1. So kalau awak tengok dekat dia punya formula ni, if you look at this formula, this looks like n, and then n plus 1. So this is the formula. So if you want to write this into the brace notation, so this is called brace notation. Okay, so this is called brace notation. The same thing like you did for summation notation. You goes from I from 1 until I equals to n. So this is almost the same thing, but this one is in because this is sequence. So you can say that this sequence is n over n plus 1 and goes from 1 to positive infinity. Okay. Ada soalan setakat ni? Any questions so far?
No.
So sequence, you can, it depends on your, on how you perceive that, how to find the formula. Okay, what's the famous sequence? Let's see, notable sequence. Have you seen this? 1, 1, 2, 3, 5, 8, 13, 21, 44, and so on. Siapa pernah nampak sequence yang ni? Awak tahun keberapa ni sekarang ni? Tahun kedua eh? Have you seen this sequence? Apa dia? Tak pernah? Tak pernah. But have you heard about this?
Yes, doctor.
Okay, so Fibonacci sequence. So this is like the next number is the addition of the previous number, previous two numbers. So yang ni antara nombor yang inilah yang paling famous. Okay, let's see. Sequence can also be graph, because I told you in the early presentation that sequence is a function and the domain is all set of integers or real numbers. All right, let's see an example. If I have, for example, if I have 1, let's see, graph of series, graph of sequence. Let's say I have the first term is 1, the second term is 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on. So you can see that you can put it into the brace notation such that you can say this is 1 over n. 1 over n, and then n goes from 1 to positive infinity. So if I substitute, if I reassign, so I assign to y equals to 1 over x, such that x, my domain is x is bigger or equals to 1. Okay, so kalau saya graphkan, so if I graph this, it will look something like this. Okay, so saya akan buat dapat apa ni? This is 1, this is 2, 3, 4, 5. Okay, so untuk yang first term saya akan dapat yang ni. Second term saya akan dapat half of that. Let's see, this is half of that. And then the third term saya akan dapat 1/3, 1/4, 1/5, and so on. So saya akan dapat a curve like okay. So in this case, kalau awak tengok kat sini, this sequence, when n or when x goes to positive infinity, y goes to 0. So meaning that the sequence has a limit that approaching 0. So the next thing that you need to know is, as usual in calculus, you need to learn to put the limit in everything. So you need to see the behavior of the sequence when the number of terms goes to infinity. Okay, so kalau contohnya kalau saya buat macam ni, let's say this is the limit of sequence. So you need to find the boundary of the sequence, bounded or not. Okay, let's see this one. If you have n plus 1. Okay, so n plus 1. So n plus 1, I didn't do this superscript and subscript. So just let's say n is a positive. So in this case, because n is the number of term, it's like counting number, you count that. Okay, so n from 1 to and so on, it's positive integers. Okay, so n plus 1. So this is growing. This sequence is growing. This is increase without boundaries. Why? Because let's say if n equals to 1, let's say n equals to 1. So the first term is 2. N equals to 2. The first term is 3. N equals to 100. So the 100 term will be 101 and so on. So it will be like when n goes to infinity, the number, the term will also goes to infinity. It's increasing without boundaries. So if you want to understand, in terms of graph, so if you graph this, so you just substitute x as a positive integer, and then x every time x increase, y also increase. So this it will look something like this. So n plus 1. So this is graph of y equals to x plus 1. So this is increasing to some infinite values. Okay, how about this sequence? Let's say this is one example, and second example. The sequence of this n plus 1, Let's see this one. Always, as always, n is positive integer. You can also have negative. I told you. It depends on your type of sequence, as long as it's integer. Okay. So how about this one? You can see that if you have n equals to 1, okay, so the first term is positive 1. N equals to 2. The first term is odd power is -1. So n equals to 3, it becomes positive back, and then negative, and then positive. So this is like alternating between positive and negative values. Okay, so this is like alternating sequence. So you can say this is the value is oscillating or oscillating pun boleh, oscillating or alternating between -1 and 1. So you go from, let's say, if you have a graph. So if you have a graph, it will be somewhere, this is -1, this is 1. So it go back and forth. This goes back right there, this goes back right there. So between -1 and 1. Okay, let's see third example. Let's say the third example, and this will be our last example. 1 plus -1/2 to the power of n. Okay, so how does it looks like? Okay, so this is let's say if n is positive, not positive, if n is even, this will be a positive. If n is odd, it will be a negative. So this is also alternating, but you can see that this is really, this is like a ratio, right? So if you have a power ratio, this value, as n goes to positive infinity, the value of -1/2 to the power of n is much less than 1, because this is a ratio. 2 will be really, 1/2 will be really a small value. So you can see that this approaching 1. So this is like approaching 1. You can say approaching 1, approaching but oscillatory. So kalau awak tengok dekat dia punya graph, it will look something like this. So let's say if n is 1, so that's something like this. So it just look like something like this. Something like that. It's really small, but approaching 1. So in this case, if you want to find the limit of a sequence, you need to see the behavior of the sequence when n goes to infinity, positive infinity, or could be minus infinity. So this is like limit of sequence. You can say that in short, I can say how does an, the bracket, the brace notation, how does an behave when n goes to positive infinity. Okay, so let's look at the definition of that. Okay, so if you want to find the convergence or divergence, you can say that you can look at your notes. Let's say if A, the detail will be in your note, you can just read that. I just want to explain this, or maybe I should, because you are mathematician. Okay, let's say a sequence is converge. AN, say the definition. Sequence AN is converge. Okay, converge to limit L given for any small epsilon positive. Then there is a n is positive such that when you have the sequence, the term an minus L, this is the same thing as your definition for limits, is less than epsilon for n is bigger than n, big N. So in this case, if you want to find the limit, so this is just limit as n goes to infinity, a of n just equals to L. Okay, so if it's not equal to some numbers, so otherwise the sequence, you can say an is diverge. The opposite of that. Okay, let's see an example. You can see that in graphically speaking, okay, just in graphic, converge. Let's say I have this tunnel or nozzle. So this is converge. Because why? Because all the value here, let's say this is A1, A2, A3, AN, it goes to some value right here. This is some value. Let's say this is L. Okay, let's say this is diverge. DV diverge. Yeah. Okay, let's say this is B1, B2, B3, and so on. Bn, it goes to some unknown values. So this is like a flow coming from the left. So this is like converging, diverging nozzle, something like this. So diverge, it doesn't goes to specific values, to any values, and converge goes to single values. Okay. Yeah, let's just erase this one. Okay, let's see some example. Okay, the thing about this is maybe the key point in this case is how to find the formula. If it's not given, then you might have to do that on your own. Okay, let's see. Let's see this one. If I have, see example. Number one, n over 2n plus 1. Is it going to be converged? Yes, any question? Is it going to be converge or diverge? So n is positive integers. Okay, let's see. So you can also use the same method to find the limits. Okay, so if you want to find the limits of an, you can just say limit of n goes to infinity of n over 2n plus 1. So you apply the same method to find the limits. So because this is a ratio, you can just use limit n goes to positive infinity. So just divide everything by n. So this is divide by n. This is divide by n. This is also divide by n. Okay, so this is will be 1 over 2 plus 1 over n. Okay, so nampak tak dia punya result, dia punya solution? So this is just equals to 1/2. So limit of n goes to infinity of, in this case, an, saya tak tulis ni. So this is just 1/2. So this is, the conclusion is this is converge. A single value. It goes to a single value. Let's see an example, another one. Okay. Let's see and alternating examples. Let's see number 2. Limit for -1 and +1 and 1 over n, and start from 1 until positive infinity. So we need to find the limits. So in this case, you can see that because you have this term, okay, when this term is going to be really, n goes to really big, you can see that this term goes to 0. And this term is not going to dominate. So this is dominating. This is not that much dominate. So even though this is oscillate between positive and negative, so this is oscillation. Oscillate between negative and positive. But this term is the dominator of this, dominate the sequence. So in this case, you can see that even you don't have to do the math right here. You can see that the limit, this one is too big, too small compared to this apa nama, this sign. So you can see that limit of n goes to positive infinity -1 over n plus 1 of 1 over n. This is equals to 0. You can also check using L'Hopital rule if you want. You can check L'Hopital rule if you want, but by understanding the behavior of this, the oscillation and then domination, right here you can see that this one goes to 0, Sn goes to 0. This one is just, so it doesn't matter if it's positive or negative. This all will be close to 0. Okay, so you can see that usually in most cases, if you have something like a ratio, in most cases, saya tak cakap semua, I don't say every cases, I said in most cases. So in most cases, if you have a ratio, usually it will be a converge. So this is also converge. VRG, Saitera Lutziger. Okay, so this is also converge. So non-converge, let's say if you don't have a non-converge or diverge. So if I have 8 minus n equals to 1 to positive infinity. Okay, so if you take the limit as n goes to positive infinity of 8 minus n, so this is goes to on the other side, on the other direction, which is minus if infinity. So this is diverge. Okay, so this is just easy. Okay, let's see if you're not given the formula, what happened? Let's see example. If I have a sequence of 1, 1 over 2, 1 over 2 cube, 1 over 2 to the power of 4. Yeah, see, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, to the power 3, and so on. Okay, so in this case, if I replace, just replace this formula, so I can already look at the formula, I can say, so this is like 1 over 2 to the power of n. Okay, the sequence is just 1, 2 to the power of n. Okay, and start from 0 to positive infinity. Okay, so what's the value of the limits? I want to find the limit. Limit of Sn goes to positive infinity for 1 over 2 to the power of n. So as n goes to positive infinity, it's really going to be quite large. So 1 over 1 divided by a really large number. So this one is 0. So that's, I don't think you have any problem with that, right? Okay. Okay, let's take apa dia? Ada soalan. Okay, let's take a 5-minute rest. We continue with sequence. Right. Okay, so ulang balik. Saya ulang balik sebab saya takut nanti ada orang tak ada. Okay, saya ulang balik. So even though this one is not converge, it doesn't completely diverge. Yang ni untuk oscillating. Usually, this is regarding power of something. It will be minus to some value or positive to some value. Okay, so bounded sequence. So we have converge sequence, diverge sequence, and bounded sequence. And the fourth part is monotone sequence. Monotone sequence. So you can see that monotone, if you understand from the word mono, it means that only one. Okay, only one. So meaning it has only one tone. So you learn this in function in calculus 1. You can have that function is monotonically increasing or monotonically decreasing. So this is the same thing. So this is the same thing. You can say, you can have something like this. Let's say I have a sequence, A of n. N is 1 until infinity. And then if I have, let's say if I have A1 is less than A2, is less than A3, and this is less than a of n. So this is like 1, 2, 3, 4, 5, 6, and so on. So the first term is, the left term is less than the term on the right. So in this case, you can see this is strictly what? Strictly increasing. Because if you look at the graph, A1 is right here, A2 is right there, A2, A3 is right there. This is not, this should be an empty bullet. So something like that. So because why? Because this one might not be the same as that one. So this is like less than, without the equal sign. So you have, that's why you have strictly increasing. So that value is strictly increasing. Okay, what about if I have A1 is less or equal than A2? Well, that one may be less or equal than A3, and also less or equals to AN. So in this case, the only difference is just you have the equal sign. Okay, you can just say, so this is like just increasing sequence. Same thing on the other hand, if I flip the sign, if I flip the inequality sign, if I have A1 is much bigger than A2, is bigger than A3, and this is the last term is bigger than AN, and so on. So I can also say this is also strictly decreasing. Same thing if I have A1 bigger or equal than A2, bigger or equal than A3, and so on. So this is just decreasing. So the only difference is what? The only difference is the word strictly, which correspond to, is it less or equal or bigger or equal, the equality sign. So in this case, if you have just, let's say this one, the word strictly right here, and the word also strictly right here, you can say in both cases this is strictly monotone. It doesn't specify is it decreasing or increasing, but it's only in one tone. Okay, same thing for these two guys, these two, increasing or decreasing, you can refer them as monotone. So this is just terminology. Okay, it can be converge or it might be diverge. It depends on the behavior of the sequence when n goes to infinity. Okay, let's see an example. We need to see the function. Okay, let's see this one. Example. The previous example, I have 1 over 2, 2 over 3, 3 over 4. Okay, so last time, just now, this is just the formula is n over n plus 1. Okay, so let's see. Let the example check the monotonicity of this sequence. Okay, let's check. 1/2 versus 2/3, which one is bigger? Which one is bigger? So this is half, and then this is like 0.6666. So in this case, this one is bigger than that one. 2/3 versus 3/4. Okay, so 0.6666 and versus 0.75. Obviously, this one is bigger, and you can see that this is like this is n over n plus 1. So this is, should be less than n plus 1 over n plus 2, and so on. Okay, so how to look at the graph? Not the graph yet. Okay, in this case, by your first definition, like here, right here, you can see that this is it equal? No, this is not equals to. So you can say this is strictly increasing. Because the first term and the second term is not equal, and it is bigger than the first term. Okay. There's no less or equal. Okay. How about the, is it converging or is it diverge? Okay. I think that this sequence is converge. Why? You can see that you can use the ratio n over n and divide that. It will be 1/1 plus 1/n. So this is converging sequence with this sequence approaching 1. Okay, let's see. I don't want to do that, but just so you know. Okay, let's see the next one. Let's see one example. Another one. This is example number 1. Example number 2. If I have 1, 1, 1/2, 1/2, then 1/3, 1/3, and so on. So this means like the first two is the same, and then another two will be the same. You can see that the sequence, the next term is 1/4 and 1/4. So it looks something like this. So if you want to put into inequality, so inequality, you can say 1 is it bigger? No, this is bigger. So 1 is bigger or equal than 1. And then this is bigger or equal than 1/2, bigger or equal. So, and the next one is bigger or equal than 1/2, and so on. So you can see that this is just decreasing, not strictly. So this is just decreasing. All right. Any questions so far?
No, Doctor.
Tak ada. All right. So this is simply increasing, decreasing. What else? Let me see. Is it the decreasing? Okay. I think that the only thing that you need to pay attention um, is the formula. For example, if is it going to be a converging or diverging function, and then you use the similar thing. Okay, let's see this one. Let's see the lower bound and the upper bound, because you have infimum or supremum. Have you heard about infimum and supremum? Saya rasa macam saya pernah pernah belajar kan dulu. Infimum and supremum. Kalau senyap tu maksudnya tak pernah lah. Okay, tak apa. So in sequence, you can also have the upper bound and the lower bound. Okay, how about the upper bound? Let's say this is related to monotonicity of the sequence. Okay, so what's the theorem for upper bound? Saya jelaskan dalam bentuk yang ringkas saja. Okay, so let's say if this sequence, say this is let's say if an sequence an is an increasing sequence, okay, increasing sequence. So there are two possibilities. One is diverge. One is you can have upper bound. Okay, macam yang tadi. This one, you can see that example number 1, this is n over n plus 1. This is strictly increasing. But if you take the limit, this actually goes to one single value. Okay, if you take the limit and goes to infinity, it will go to a single value only. So if n is increasing, you have two types. Is it diverge? Is it going to diverge? Or is it going to go to some limit which is called upper bound? Okay. So what's the upper bound definition of this? So if I take that an is less or equals to m, so for all n, and then I have, when I take the limit n goes to infinity, positive infinity of an, this is equals to L yang tadi, yang untuk definite tadi, and then L is less than m, so we can say that m is the upper bound. So m is this is the upper bound. Okay, how to understand this? Let's look at this example. same, I'm using the same example, 1 over 2, 2 over 3, 3 over 4. So if I take this example of, let's say I substitute n over n plus 1. So put it in terms of x, and this equals to y equals to that. Okay, so if I plot this, how does it going to looks like? So it start from 1/2. Y start from 1/2. Just the graph. Y start from 1/2 and then increasing. And then this one is approaching 1. So this one is approaching 1. So that's why. So if you take the limit is equals to n, and limits is equal to L, and then L is equal to 1. In this case, this is 1. Okay. So the upper bound on this case is 1 if you take the limit. How about the lower bound? So you just reverse the definition of this. So if an is a decreasing sequence, the same thing happen also. You can have a diverging sequence, or you can also have a limit, and that limit is called lower bound. So there are two possibilities. So the diverge, the same thing, diverge. So anything goes to minus infinity because this is decreasing. So it might goes to the limit, goes to minus infinity. Before that, so diverge is goes to positive infinity. Why positive infinity? Because this is increasing. Same thing right here. Why it goes to negative infinity? Because this is decreasing. Decreasing goes to minus, really big minus number. All right. Let's see. Let's say this one. So if I have, if I take an, all the term is much bigger than m, and then if I take the limit, n goes to positive infinity of an, this is equals to L, and L is bigger than m, so m is this is the lower bound. Okay, so let's look at the graph of this. Let's try to understand from graphical point of view. Okay, let's see. Let's take an example from this case. Previous one, we have y, not y. You can see y. This is 1 over x. So this is coming from the sequence of 1 over n. So then you translate into Cartesian coordinate. Okay, so in this case, y start from 1 because that 1 over 1 is 1. So in this case, I can have my graph looks like this. So this is 1. Okay, and then the next one is over there, 1 over 2, 1 over 3, 1/4, and so on. So it is increasing. Is it exactly equal? No, it's not exactly equal. So in this case, this line, the lower line right here, is my lower boundary. So this is x-axis, y equals. So this is my lower bound. Because every term is bigger than this one. So this is decreasing. This is a decreasing sequence. So you can see that maybe you, if you want to understand this, just use your sketching. Just use sketching. Okay. So for example, if you have, if you don't understand this, you can use sketching. For example, if I have something like this, and then start like that. I don't know, maybe like that. So because this is increasing, okay, because this is increasing, it might goes to a like macam atap lah. So it might go to something underneath that. So it might not, mungkin ada atap, mungkin tak ada atap. So this is the upper bound. Okay, so you have upper bound. If this function is decreasing, start from a big value, and then the next value is small, small, and small. It might go to the left or to the right. So this one. And then it might touch some floor. So this is macam lantai. So this is the lower bound. So that's how you understand that. Okay. Just this is just like an explanation. Because student, sometimes you guys are not sure. I'm not sure, is it going to be a lower bound or is it going to go to upper bound? Okay, so if it's increasing, it should be an upper because you go up. If it's decreasing, it should be low because you are going to a low value. Okay. Any questions so far? Tak ada. Alright. So kalau tak ada, let's look at the next one is series. Series. Okay. So you can see that the sequence is just just like A1, A2, A3, and A so on. Okay, so in your high school mathematics, dalam math, awak pernah dengar arithmetic series and geometric series. Okay, so this is the same thing, except that we might not have, more than 2 of those series. It might not be necessary geometric, or it might not be necessary the arithmetic series. Okay, what about series? Okay, series is like the sum of the sequence. Okay, the sum of sequence. How does it looks like? So we can use the summation notation. So this is equals to, let's say, I equals to 1 until infinity of u of I. So u of I is what? U of I is start from 1, u1 plus u2 plus u3 plus and so on. The same thing. So this is the first term. This is the second term. And then if you have something like that, this is the n term. So you can see the difference between what? Between sequence and series. Okay, example. Let's say this number 0.333333 and so on. This can be viewed as series, as an infinite series. So this is because you have this is infinity, it will be infinite series. In most cases, we are talking about infinite series. What happened when I goes to infinity? Okay, I can also understand this as a sequence of, this is also a sequence of 0.3 plus 0.03 plus 0.003 plus and so on. So if I want to put it into fraction, I can say this is just 3/10 plus 3/100 plus 3/1000 and plus 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 plus. So in other words, I can break it also. Let's say I can also do something like this. So this is 3/10 plus 3/10 to the power of 2 plus 3 to the power 10 to the power of 3 plus so on. Okay, you can see the pattern. Okay, if you want to see the pattern, you need to see the formula for this. So what's the formula for this one? That looks like 3/10, 10 to the power of n, right? So I can say that this one, so Sn is equal to that n term. And I can see that the formula is just Sn is 3 plus, so Sn is just the summation of this, the series, infinite series of this is 3/10 plus 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 3/10 to the power of n. So that is my formula. Okay, so how to find this? You can do something like you can put it on the right and then put it on the left. Okay, okay. I can do something like this. I want to find the limit. What happened to the limit when n goes to positive infinity for Sn? So, if you remember, what's the summation of that in terms of fraction? So this is just equals to. So actually, this is just equals to 1/3. Why? I don't want to talk yet, but I just because as you can see that if you do the fraction, it will be 0.33333. So this is how you do in, if I'm not mistaken, you already did this in your in your high school. Okay, but I will show you the next step for that. Okay, so this is just introduction. Okay, let's see the type of series. You knew that you have one, number one, you can have geometric series, and number two, you can have arithmetic series. Okay, so what we did just now is geometric series. Why geometric series? Because you have something to the power of something. Okay, so you have something over something to the power of something. Okay, so what's the formula for that? So geometric series is just when you have summation of k equals start from 0 to infinity a of r k. So you have something to the power of something, and then if you expand this summation, you have a plus ar plus ar squared plus and so on. And a is obviously is not equals to 0, because if it's 0, then it doesn't mean anything. Okay, so r is what? R is the ratio for the series. K, how about k? Can k start from 0? Yes. Can k start from 1? Yes. It depends on your series. So it depends on what you are trying to do. This is can also start from 1. But in general, in most cases, we start at 0. Why? Because you have 0 power. It gives you a constant value of 1. Okay, and then what's the sum of this? The sum of this is just, so this is just equals to a over 1 minus r. So what is r? R is the ratio. A is what? A is just the coefficient of that. For example, if I have 1 plus 2 plus 4 plus 8 plus something something, so this looks like 2 to the power of k, because this is like this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So this is like 2 to the power of k. Okay, and then we have a equals to 1, and then r equals to 2. So in this case, if I want to find the summation, it will be 1 over 1 minus 2. Oh, before that, saya lupa satu lagi. Before that, I forgot to say that. Before that, let me trace back. R is the ratio. So since you have a ratio, R equals to ratio. So you can have, I told you just now, in sequence, that if you have R is the magnitude of R is bigger than 1, bigger or equal. So this is diverge. If I have R is less than 1, so this will be converge. Okay. Because why? Because you can see that if you have R is less than 1, then the power will be a minus power. So if you have a minus, it will be a decreasing function. Okay, let's see. This one is this. How about the one that we did just now? 3/10 plus 3/10 to the power of 2 plus and so on. So this is 3 to the power of 10 to the power of n. Okay, so let's see. This one, the A is just 3/10. And then R is just 1/10. You need to see the ratio. How about this one? 1 minus 1 plus 1 minus 1 plus 1 minus 1. How about that one? Let's look at the formula for that. So this is like alternating series, alternating sequence. Okay, so it looks something like this that we did just now, minus 1 to the power of k plus 1. Okay, so in this case, you have A equals to 1, and then R equals to minus 1. So A is just the coefficient. So in this case, you can see that this is the absolute values of minus 1 is 1. So this is diverge, but it is bounded but diverge. Bounded but diverge. All right. Any questions so far? Okay, so kalau tak ada soalan, let's look at this one. Example. If I have summation of k equals to 0 to infinity x to the power of k. So in this case, I didn't specify this value x. Okay, what to do in this case? So we can just expand this first. So it will be x to the power of 0 plus x to the power of 1 plus x to the power of 2 plus and so on. Okay, so this is just 1 plus x squared plus and so on. Okay, by the way, series and sequence is, you might think that what does it has to do with calculus? Okay, actually dia ada banyak dia adalah macam basic, your most basic most basic topic in calculus. So you need to bear with me, even though you might think this is quite boring, because this is the same that you did in high school. But if you see the, what do you call it? Apa nama? If you see the big picture for sequence and series, you can understand that this is really important to go in the next level. Okay, so let's see this one. How about the sum of this? Okay, so you can see that x r equals to x and a is equals to 1. So the coefficient of this is just 1 because we don't have anything else. So Sn for this is just a over 1 minus r. So this is just 1 over 1 minus r. Not r, this is x. Okay, so in this case, you need to see the behavior when x, what happened to x equals to 1, what happened when x is bigger than 1, bigger or equal. Okay, you can see that if it's equal, this will be diverge. So in this case, you can say that if x, the absolute value of x, is less than 1, so it will be converge. Otherwise, it will be diverge. So this is like the same notification, not notification, the same thing that you did for domain and so on. Because if you take the domain of this function, as I said before, sequence and series, it has some connection to your function. Okay, so if you take this series, if x equals to 1, this will be goes to infinity, and if it's x is bigger than 1, the absolute values will be a really big number. Okay, let's see this one. Example, determine if this series k start from 1 to infinity, 1 over k times k plus 1 converge or diverge. Okay, so you need to determine that. So before you do that, I think it's better if you expand this. So if you expand this, it will be 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus and so on. Okay, and then until 1 over n plus 1. All right, so if I want to rewrite this, I can also write this in terms of 1 over k. So this is like 1 over k, rewrite 1 over k, k plus 1. So I want to write in terms of partial fraction. Okay, saya nak buat dalam bentuk partial fraction sebab saya tak suka ada multiplication kat sini. So I can do something like this, k minus 1 over k plus 1. Okay, I think you are already good at partial fraction when you do the integration. So you can just do something like that. Okay, and then saya boleh I can put it back into my this sequence. So this will be, put it back, into my series. So what's going to happen? So 1 over 1 plus 2. So the first term right here is just 1 over 1 minus 1 over 2. Okay, so this is for this one. Okay, and then plus the next sequence is this. So this will be 1 over 2 minus 1 over 3. And then so on. So this is the nth term. So the nth term will be 1 over n minus 1 over n plus 1. So this is this term. Okay. So sebab apa saya buat macam ni? Sebab saya nak tengok awak nampak dia punya ni. Okay, let's look at this one. You can see that yang ni ada, this one you have, let's use green. This one is minus and then plus. Obviously you can see that kalau kat sini pun dia akan jadi, this will be 1 over 3 plus, not plus, minus 1 over 4. So dia macam ada cancel out. This will be cancel out. So dia punya term second dan third dia akan cancel, third dengan fourth dia akan cancel out. So yang tinggal kalau awak buat sampai kat sini, so if you do until this, it will be 1. Okay, yang tinggal dekat yang 1 per n minus 1 over n plus 1. So this is positive, this is plus positive. So dia akan ada kat sini minus 1 over n kat sini. So dia yang ni dia akan, yang ni semua jadi kosong. Okay, yang ni pun dia akan cancel out juga. Okay, so apa yang tinggal? Yang tinggal hanyalah kenangan. Okay, so yang tu saja je saya ni. Okay, so yang tinggal apa dia? Yang tinggal only the first term and the last nth term. Okay, so nampak tak dia punya ni? Nampak tak dia punya ni? So I can see that the summation, saya boleh buat kesimpulan, last part. Saya boleh buat kesimpulan bahawa last one is k equals to 1. The series of this k over k plus 1. So this is equals to when the limit, take the limit, n goes to positive infinity of Sn. So the summation, this is the summation. So this is just equals to when you have the limit. So this is Sn. Okay, so this is Sn. When n goes to infinity, so this is just limit of n goes to positive infinity, 1 over 1 per n plus 1. So this one is equals to 1 because this one is big number. So this is goes to infinity. And this one, the whole thing will be approaching 0. So this is the value. Okay, so saya rasa saya tak sempat nak, kalau ada soalan pun saya tak sempat nak jawab. Okay,